Good afternoon, everyone. Welcome to the second session of today's conference. Today, um, I'm here to deliver a lecture on the geographical location of propolis and how it affects the chemical composition, and in turns how it affects the biological activity. To study this correlation, we used SPSS as a statistical tool. I thank you very much. Thank you, James, and the IPRG conference organizers for inviting me to deliver a presentation on a very interesting topic where we had very good discussions by earlier speakers where they explained how propolis can be a sustainable medicine. So for this study, when we did a literature search, collected a material for applying the statistical tool, we found that we divided the samples from those regions in three different zones: temperate, subtropical, and tropical. So the reports and studies from polar and subpolar zone were very limited. So as a requirement in SPSS, you should have 20 valid cases. So we had to merge them with the temperate zone, as it is their composition was most resembling with temperate zone. This is the list of countries as we sorry, excuse me. We use the material or the reports from these countries. This list is not exhaustive, although the majority of the reports were from these countries. And in this study, we decided to keep the anti-microbial activity as a dependent variable, and the numbers are those studies were reported in MIC, and we decided for various important chemicals which we found frequently or generally available present in the propolis from various regions. So we selected almost 13 individual chemicals and 2 independent variable as total phenol content and total flavonoid content for this study to see the correlate their presence and level in propolis, how it affects the biological activity. So as I said, we divide, these are the 4 major class of chemicals we selected for the study, and these are the cinnamic. So we merged the cases or the reports where caffeic acid, coumaric acid, ferulic acid were reported as a cinnamate. So we added the number, like if a sample has caffeic, coumaric, and ferulic acid in 100, 200, and 300 microgram per ml. So we merge them together to make it kind of 600 microgram concentration in that sample, as they are biologically and chemically closer and related. In this study, we had set some criteria, so we cannot take all the studies for consideration, as we decided 500 microgram per ml concentration. Any propolis which is showing MIC above 500 microgram per ml, we considered it as a less active and did not include that study in the analysis. Again, there were many various analytical techniques used for analyzing the chemical composition of propolis. So we just selected HPLC to have uniformity in the data and to avoid putting in the lots of errors. Similarly, for the antimicrobial activity, we found aureus was commonly used for the biological study to screen the biological potential of propolis. We did not select other microbes. Obviously, there are reports where people use different bacteria, gram-positive, gram-negative bacteria, but we just selected aureus to keep uniformity in the study and to avoid incorporating the errors. This table shows the the mean value which we found for almost more than 470 case studies or samples reports we selected in this study, we found that the total flavonoid content is almost more than double and compared to the flavonoid. And if you see the correlation here, the total chemicals present in tropical is less, I would say, microgram phenol and flavonoid, right, compared to subtropical and temperate. But the biological activity of a tropical is almost more than temperate and almost slightly less than subtropical. So tropical propolis has unique composition, although their level total phenol content is less compared to these, the activity is comparatively higher. So this is our finding from the running the descriptive statistics for the selected 470 reports. This table is very interesting. It shows the median value of abundance of these individual chemicals in the propolis from all three zones. So what we found, the concentration of pinocembrin and chrysin and galangin also, and in temperate pinobanksin as well, was consistently high and throughout the all climatic zones. So if we want to develop a global standard for a propolis, and if we want to see which excuse me, then these four chemicals can be used as a marker to check the standardization, to perform the standardization study of a propolis and check the authenticity or the quality of a propolis. This is a screenshot of SPSS software where you can see here almost 170 cases where the reports were selected for the study. We performed imputation here, multiple imputation, because lots of cases where the reports were not present. So the empty cases incorporates a lot of error in the study. So we had to impute, and the software gets the value based on the earlier reports for those chemicals, for those variable. This is a descriptive statistic for all the pooled imputation which we performed in SPSS. I'll just take you through this, the correlation table which we, after running the correlation analysis, multiple correlation analysis, we got this output. The model summary, it shows that the R value is higher. It's higher the R value, better your model you are using for analysis is considered. So closer these value towards 1, these value closer to 1 is considered better. And the F value also, the P value also suggests that the model which we used is significant as number is less than 0.05. The ANOVA table also suggests that the statistical model we used is significant as the significance is less than 0.05. And this is the coefficient table from the pooled data for all the imputations, 5 different models, the best pooled values for coefficient. What we interpret from ANOVA and model summary table is that the statistical model we used is significant as it is less than 0.05. And in the correlation analysis, the dependent variables can predict up to 54.88% of independent independent variables can explain 54.88% of dependent variable, which is antimicrobial activity. So what we can interpret that the relation between the independent variables and antimicrobial activity is moderately strong. So this is the regression equation. If you know the concentration of individual chemicals in the propolis, including total phenol and flavonoid content, and you can guess the microbial activity, and that we have labeled it or defined as a or identified as a propolis bioactivity quotient for the antimicrobial activity of propolis. So yeah, now this is just a number. Why is just a number? So how you can read it? So we have published a review article for antioxidant activity. In this line, you can say that any PBQ less than 100 is the propolis can be considered very high. Similarly, if the PBQ is more than 500, it can be considered as a less active. So similarly, what we did is for antimicrobial, similarly the PBQ for any other condition can be developed. So antioxidant or anti-inflammatory or antiviral, anti-cancer. But one thing you have to remember, when you are performing a PBQ for just say anti-cancer, and then we all know that prazoline propolis has a typical chemical composition which contributes to its anti-cancer activity. So those chemicals are needed to be included as an independent variable in your study. That will give more confidence on the output of a study or the whatever prediction we do. So in the conclusion, what we observed that the flavonoid content is higher, almost 1.5, more than 1.5 times. And the phenol has a better correlation to antimicrobial activity compared to flavonoids, because flavonoids considered to be antioxidant and anti-inflammatory. And the cinnamics in flavonoid contributes to biological activity. And the independent variable explains the 54.88% predictability of antimicrobial efficiency of a propolis. What we also found that the galangin, cinnamic acid, and hydroxycinnamic acid are reported in higher concentration in tropical propolis. And to particularly mention, the apigenin contained in tropical propolis was way higher than other zones. The higher the concentration of pinobanksin, pinocembrin, and chrysin was found in propolis from temperate zone, although they are found in higher concentration in all other zones. So the PBQ for those 470 reports which we selected for a study found to be 188.92. Thank you very much.